Okay, we're going to start with the mini lesson of lattice energy. The first thing I want you to know, it's very simple, is that the word lattice has to do with ionic compounds only. Ionic compounds, their shape is described as a lattice, meaning they're very structured, very cubic looking, structures. They're very ordered. That's the worst picture I've ever drawn, but very ordered, very crystal-like type structure. So if you learn that the word lattice means has to do with ionic, it will make your life a lot easier. So on your packet, it's talking about lattice energy. And lattice energy is the energy needed to break the ions in an ionic compound apart. So like if you had NaCl, we always say that that breaks up into Na plus and Cl minus. So it would be the energy needed to separate those ions from each other to get the Na plus and the Cl minus. What you are going to have to be able to do is to predict, looking at different compounds, which one will have more or less lattice energy, which one requires more or less lattice energy. And so what they'll usually do is give you a list of compounds and ask you to decide. If you look on the third bullet of your packet, you'll see that the number one factor in deciding this is the difference in charges. Okay, so the first thing you're going to look is at the charges. The second factor, and we'll discuss both of these, I'll show you with an example. The second factor is going to be their radii, how big those atoms are. So the example I have on your packet there is we're using NaF, CSI, and CaO. Okay, so if you think of those in terms of their ions, Na breaks into Na plus and F minus. CSI breaks up into Cs plus and I minus. And then we have Ca plus 2 and O minus 2. So we said the first most important factor are the charges. So if you look here, the difference in charge, we're going from a plus 1, we have a plus 1 to a minus 1, also plus 1 to minus 1, and then this one's plus 2 to minus 2. This is a bigger difference in charge, obviously, than the other two. So this one right here immediately sticks out as having the highest lattice energy. We'll just call it Le for short. So that's going to have the highest lattice energy. We can't use that difference in charge, though, to determine those ones, and they've asked us to rank them. So we know right away that CaO is going to have the highest lattice energy, but I need to figure out the order of the other two. So I can't use difference in charge. It just doesn't work here for those ones. So then we want to look at the radii. Now, if you look on the periodic table, just based on energy level, you can, well, I should probably point to this one. You can see that Cs is bigger than Na. So we can see that. Also, if you look at the anions, it really doesn't matter which one you look at in the examples they're going to give you. You can see that I is bigger. Oops. See if I can spell bigger today. And this one's smaller. So again, look, the smaller ones were with NaF. The bigger ones were with CSI. So whichever one was smaller, we said was going to have a hold or grip on each other, more nuclear charge. The nucleus holds on to those everything harder. We talked about that with ionization energy, all sorts of things. If that nucleus is close to those electrons, it can hold on more tightly. So that's going to be the next hardest one to break up. That's why NaF should be there. And then CSI would be the easiest because it has the smallest difference in charge and it's the larger of the ions. They'll be easier to pull apart. Now, also on that same page, there's a note about variable charge metals. You do not need to memorize those. They're really there just to kind of give you an idea of the more common ones that we'll be seeing. You're not going to be given a question that says, list the possible charges for chromium. But I just wanted you to see them. I felt like it was something that's worth taking a minute or two looking over. So just take a peek at those just so that you're aware of the more common ones. Because, for example, there aren't compounds that have copper with a plus 3. It's plus 1 or plus 2. So you would know maybe of a mistake if you saw one with a plus 3. So that's really why I wanted to bring them to your attention.